Hey, all you astronomy nerds out there. Hope everybody's doing well. It must be, it must be really, really, really close to 2 hours UTC. I can feel it. I can feel it. I'm watching the clock. I'm watching the clock. Starting a little early. Starting a little early tonight, just for fun. Still trying to work out that countdown clock thing. I think I've got a good countdown clock, but I don't know if I should start early or right on time or what, because I mean it just adds minutes to the live stream that you know everybody's still joining the circle. There it goes. All right, 2 hours UTC. It must be time for Astronomy Daily Live. Hope everybody's doing good. Hope you had a great day, great evening, great afternoon. The past 23 hours, we have more or less traveled about 20 million miles, spinning around the Earth, going around the sun, and moving around the galaxy. 20 million kilometers we have moved in the past 23-ish hours or so. So hope that was a good ride for you. I'm going to, what I should do is I should tweet that I am live. So let me go ahead and do that really quick. I had a, uh, I had a like a power failure of some sort, like 10 minutes before 2 hours UTC. And so I had to sort of scramble to get everything going again here. But I mean, it's not really a scramble. It's just instead of just having to sit back and relax, drink some coffee, cheers, had to restart everything and make sure everybody's everybody's running. So yeah, it was just a pain. You know how that goes. So yeah, I'm going to tweet out the fact that I am live. Let all my followers know that I am now live. I'm trying to build this audience. It's uh it's definitely challenging. Challenging to see those numbers going up a little bit. I'd like to see the numbers go up a little bit. I think they will eventually. Just have to have a little bit of patience uh, and some relatively good quality stuff. And so I hope I'm delivering both of those things. I'm gonna tweet out the link here. Copy, paste, and now I'll add a little graphic. Always have to add a little graphic. Here we go. Hey, all you astronomy nerds. Astronomy Daily Live has just begun its latest live stream, starting at 2 hours UTC. Come join this circle of friends who all share a similar passion for astronomy. Newbies, amateurs, and pros are all welcome. So that's what it says on the tweet. Tweet, tweet, tweet. So I'm going to go here and load that in so I can watch the channel as it goes. I can watch the chat. Uncle Bill is already waving in the chat. Glad to see you again, Uncle Bill. Hope everything's well where you are. Everything's really, really nice here in terms of weather. Really, really, really nice. So we had a little bit of cold, a little bit of wet. We had some snow. We had some snow. But the great thing about snow where I am, the greatest thing about the snow where I am is that it doesn't last. So yeah, you got to excuse sort of the scruffiness here. It's just cosmic being lazy. It's the lazy cosmic dude. So and that just happens. So but this is going to go away soon. I just haven't gotten around to it yet. So hope everybody's doing good. Let's talk some astronomy stuff. What is going on in terms of astronomical things. I watched some of the astronomy cast today with Fraser Kane and Pamela Gay. They were talking about, uh, once you have a rocket in orbit, um, what's sort of next in terms of being able to move around and all of that. Past the first stage, past the second stage, past the third stage, you're trying to get out of the gravitational influence of the Earth. So how do you do that? And so yeah, they had a great discussion about that. And yeah, I'm looking forward to seeing the entire show because I just caught a little bit of that today. So yeah, hope everybody's doing good. Uncle Bill, any questions, comments? Did you get a chance to look at that JWST report? Um, it's yeah, it's a little interesting. It's a little scary to hear that they're having little snags in the fabric that is supposed to protect the telescope from extreme heat. So, getting little snags this late in the game, I don't know, it's making me a little nervous. I think they need to fix that. And personally, as I said last night, I don't care how long it takes. I don't care how long it takes. Get it get it fixed. Get it right because pretty much pretty much when you launch that sucker, okay, it's gone. It's gone. So if you don't have it right, that's going to be a disaster. That'll be a big, big, big loss. Um, you know, the the knowledge and the experience won't be lost, but all the material and you know, uh, we'll always have to think about what could have been, right? So get it right. I think they're going, at least according to the report. Hey there, Tom. Hope you're doing well. Um, I hope, yeah, the report said that they were going to unfold and fold the um, the the protective blanket. I forget what term they use. They were going to do that like 4 times total, and the first time, it hit this little snag. Right, it snagged up on something, and they said it was going to be an easy fix. So hopefully it is. So they're going to try that a few more times. Hopefully there aren't any more problems with that, because yeah, we got to get it right. We got to get it right the first time. That's really hard. That's really, really hard. But you've got some smart people. You've got some good people there. You got some smart, smart, smart people. So I have absolutely no doubt. And if it runs over time, which means um, over budget, who cares? Who cares? That's fine. So what? So what? We're going to have a cool, cool, cool instrument that is going to help us understand, uh, you know, um, understand the universe a little bit more. And as far as I'm concerned, that is very, very cool. I would like to see more space telescopes. Um, the one space telescope that we sort of have access to, the Hubble Space Telescope, is more or less the only one that's available to professionals, and that really sucks because that means that it's incredibly oversubscribed. Right? There might be thousands and thousands of proposals. You know, um, um, requests for um, um, observations, and maybe only a handful are able to be doled out because there's only one telescope, and it's pretty small too, right? I mean, I think it's a 90 inch, right? It's like 2.3 meters. So I mean, it it's adequate. I mean, obviously, it's adequate. But what I would like to see is maybe 10 or 20 or 30 of those up there. So, the astronomers can get the telescope time that they want and need and do some really, really cool science. What if we had access to as much space telescope time as we wanted? What could we do? What could we find out? What could we learn? I don't know, and we're going to have the same problem with JWST, right? Even more so, because that's one telescope, one extremely awesome telescope that is going to be doing some extremely awesome science, but it's one telescope. So there's just not enough time. There's not enough time, and it's going to be completely oversubscribed as well. So I'm an advocate for JWST for sure. Go baby, go! Right? Get up there, get up to the L2 point where it's nice and dark, nice and cold. Take a look around, get some good, awesome, awesome, beautiful data. Okay, hopefully that thing is going to be up there for years and years and years and years and years. We're going to find out all kinds of awesome, awesome stuff. And that's very cool. But it's one telescope, right? It's just one telescope. And we've got, hundreds and thousands of astronomers on the ground that want, you know, maybe not that kind of data, but they want space telescope data. Good, high quality, high resolution data, not just images, right? They do spectroscopy. Um, we should find out exactly what instrumentation is on HST. I don't even know anymore. Don't even know. So we should try to find that out. Maybe I'll make that a live stream where we just go through all the instrumentation that's on HST, uh, and sort of, just find out what the different instruments are called and basically what they do. Yeah, that kind of be interesting. I need a refresher course in that anyway. But yeah, I would like to see 10 or 20 or 30 or 100 HSTs up there. So the astronomers, and maybe extend that past um, professional astronomers and get other levels of astronomers out there, collecting data with a space telescope. I think that would be very, very cool. I mean, really, to get time on any telescope at all, it's all you need is some of that. It's all you need, and you need a good idea, right? So you can't well, you probably can't bribe anybody. So you have to have a good reason, to make the observations and collect the data, and you need ching 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 ching, and that's it. So if you have those two elements, you can um, collect your data. Going to have to go through all the reductions of your data to make it so you can understand it, and then you have to do the analysis, and you have to come to some kind of results. Is the data good? Is the data bad? Are the results okay? Et cetera, et cetera. So that's on you, and there's a lot of tools to do that too. But to get the actual data from the telescope, you you need a really good plan, and you need a lot of money. And that's it. That's all you got to do. Cheers. It's coffee tonight. This is the meager 10% Kona, which, all right. All right. Cheers. And tonight it is dihydrogen oxide. I still have to find out if it's supposed to be dihydrogen monoxide, but it is H2O. So dihydrogen oxide is H2O. And yeah, it's just very energetic, very energetic. One of the most amazing molecules in the universe, for sure. Wouldn't you agree that dihydrogen oxide and hydrogen hydroxide are two molecules that are just amazing? Absolutely amazing. Cheers. Mm, yeah, awesome. What I wanted to do tonight was step back a little bit. I haven't done this in a little while, and just show some tools that I use to you know help help me prepare observations and do observations. And one of the most important things uh, in preparing for an observation is the weather. Is the weather, and I sort of talked about this last night in terms of forecasting, and how really what I would like to see in a forecast is is the confidence level in a forecast. So you can make a forecast that is for the next hour, and the confidence level is probably pretty high, right? It's probably 90% maybe. Um, but as you extend that forecast out to a day, 2 days, 3 days, a week, a month, that confidence level in the forecast goes down and down and down and down and down. And personally, I would, I mean, when they make a model, okay, when they try to model the weather, okay, one one of the values that I'm absolutely certain are going to come out of that model is how confident uh, are they that this model is actually going to match what actually happens. Okay, um, uh, uh, but that information, I haven't been able to find that kind of information yet. I would really like to find it. If anybody knows where I can find that kind of information, maybe I just have to look at the models themselves, which I've never really done, because they're probably really complicated, and I have to try to figure things out, and I'm tired of trying to figure things out sometimes. But so maybe it's just a matter of looking at the models and finding in the numbers. But I would think that forecasters could, and I hate to use the word, but simplify it such that people can understand, because people are not going to understand confidence level. Although internally they do, because they talk about how you know how um, um, forecasters can't really do a good job, right? Well, that's a measure of confidence. Anyway, I'm not going to diverge into that. If anybody knows where I can find that kind of information, like a confidence level in the model, put it down in the description, or if you're in the chat here, you can also go to my Discord channel, which is also linked down in the description below. Uh, I don't know if somebody who's already on the server has to invite somebody new in, or if somebody can request to join. I don't remember. Maybe Uncle Bill, you probably know those kinds of things. Um, does somebody sort of fresh coming into Discord, do they have to find somebody to invite them into a server, or can they make a request to join? I don't know. I'm still too new with Discord. Although I like Discord, I'm liking Discord even more, and I'm understanding uh, why Tony with um, Deep Astronomy. Shout out to Tony. Awesome, awesome, awesome show. He's on Wednesdays and Thursdays at, I believe it's 3 p.m. Eastern time in the United States, which I believe is 20 hours UTC. So he's on Wednesdays and Thursdays at 20 hours UTC. Anyway, he really likes Discord. And I think if he had his way, there would be one chat, and it would be the Discord um, Deep Astronomy chat. Okay, so Uncle Bill says anybody can click that link and get in. Okay, okay, cool, cool. They do they need to make a request in order to join? I don't think that they can just automatically join, can they? They have to make a request. I have to, well, the owner of the server, right, has to approve. I've got a little friend here. I've got a little friend. He's decided to make ears his ears available. There's the rest of it. Well, there's the rest of his head, at least. Hello there, bud. What's happening? Coming up, purring and purring. Yeah, hi. Okay, we're going to talk about the weather because the weather is really, really important to most astronomy. Uh, Radio astronomers are sort of the exception to that. Um, in radio light, the atmosphere of the Earth is transparent, which means when you look out into the radio sky, except where there are radio sources, it's completely black, right? It's already dark. I don't probably have to worry a little bit maybe about the rain, but I don't even know if you have to worry about rain and snow all that much. So you definitely don't have to worry if it's you know daytime or nighttime. Hi, you trying to chew my thumb? Yeah. Oh, thank you so much. Oh, yeah, that's great. Thank you so much. Um, but other astronomers who are working either in um, visible light or the infrared or submillimeter, even to a pretty large extent. No, you cannot play with the cord though. If you play with this cord, you're going to have to go. Yeah, I need this cord in order to talk to these nice people out here. Yeah. All right, you're going to have to go. Off you go. Well, hold on a sec. There. Okay. The rule is you cannot, kitties cannot play with cords. It's just ain't going to happen. So visual astronomers who are using, you know, regular optical telescopes are, of course, very, very concerned about the weather and also the time of day, right? Because it has to be dark and it has to be clear, and you have to have those two factors working together in order to have a satisfying um, evening of observing. Cheers. So getting a good forecast is tough. And what I use, I'm going to share my screen. What I use is the site this site called cleardarksky.com. So if you go to cleardarksky.com, you sort of get this first, like, this front page, right, which is not incredibly useful, and fonts are all crap. It just not a very pretty site. But I don't really care if sites look good or look bad. If it has the content that I want, that's all that matters to me. Anyway, if you go to Clear Sky Charts like that, then you'll come to this, which is sort of the front page, right? The Clear Sky Chart home page, and it gives an example of a clear sky chart. So they give a little explanation for what it is and blah 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 blah. But then you can find, or you can point to a location, right? Location either where you are or where you're going to be to make an observation. So just as an example, I will go relatively near me. So I'm in the state of Arizona, and then here's all the telescopes that have registered with clear dark sky to to give their positions so they can have their own clear, clear dark sky chart. And so I'm relatively close to what's called the Chiricahua Astronomy Complex, CAC. It's operated by the Tucson um, Amateur Astronomy Association. An awesome, awesome, awesome group of people. Um, but it is just a regular club, and they have a monthly meeting with presentations, and it's usually a very very big crowd. There's usually 50 to 60 or more uh, in the crowd, and they have a talk, and they talk about what the club is doing, the star parties that they're going to, et cetera, et cetera. So if you're new to astronomy, okay, if you're brand new to astronomy, the first thing that you should do, the first thing that you should do is find a local club and start going to meetings. It's usually monthly, like the first Friday of the month, or something like that. Um, and start going to um, um, the meetings. The membership is usually very enthusiastic, very knowledgeable, and they love to talk about astronomy. And they like to talk about what telescopes they have and what they've been observing and all all of that. So if you're brand new and want to get into it, find a local club, and there are local clubs everywhere, everywhere. And if you need help finding them, send me an email, cosmiclettuce@gmail.com, and we'll find you a local club. They are everywhere, um, worldwide. Worldwide, they are everywhere. There's a very, very, very active um, community um, in the UK, right? Just absolutely awesome, absolutely awesome. All right, so what this clear sky chart presents to you, and can I? Yeah, no, this is about as big as it goes. What it presents to you is along the top, you'll see that it says Friday, Saturday, Sunday. See, this is just a couple of days. This is just a couple of day forecast. And what that tells me, and I think that this is absolutely true, is that after after a couple of days, confidence in the forecast drops below a certain threshold, right? And so everything sort of past this is questionable, right? You really can't be sure what's going on there, but you can see that it shows the date, right? The current date, which is Friday, and then the local time. So 8 a.m., 9 a.m., 10 a.m. Here's noon. Here's 1 p.m. Here's 11 p.m. And then it goes to 12 midnight, 1 a.m., 2 a.m. Blah 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 blah, like that. So the columns here, right? The columns is just the hour, right? So let's look. My local time right now, I'm in Mountain Standard Time in the United States. So that means that I'm 7 hours behind Coordinated Universal Time, which is 2 hours UTC. So I've got to take that 2 hours UTC and subtract 7 hours from that. So when I do that, um, it's currently 2:28 UTC, which when I subtract 7 hours from that comes to 7:28 p.m. Mountain Standard Time. So 7:28 translates to 1928. So this right here is sort of my current time. And so this is what my conditions were at least forecasted to be. And that is cloud cover says is clear, right? When it's this nice shade of sort of a dark sky blue, that means, that's like nice, clear skies, right? Transparency is sort of the same thing. Um, that's just, if there's like any high altitude clouds that may be obscuring a little bit, don't necessarily call them clouds, but it's more like a haze, right? How hazy it is. Um, and again, this is saying that the sky is transparent. Now the seeing is sort of how bubbly the sky is. There's um, water vapor and dust and all kinds of crap in the air, and it's constantly in motion, and it's that motion that causes the stars to twinkle. And so the seeing is sort of a measure of the twinkling. And as you can see, as of at least the forecast is saying that as of right now, the seeing is average, 3 out of 5. So what that means is that if I were to go out now and look up in the sky, the stars would be, um, um, twinkling, sort of. I would sort of notice twinkling. Now it looks like earlier in the day, it was actually poor seeing. So hopefully it's improved a little bit. And this fourth row is just a measure of darkness. So of course, during the day, it's uh, not dark at all. And at night, it's quite dark, but you can sort of see that it's not black. You see how it's black right here? And then it gets sort of this light blue? Well, the reason why is because the moon isn't out. And the moon is going to rise and the sky is going to get quite bright. I don't know if you noticed the full moon last night, but it was just beautifully bright, incredibly bright. And then we go into daylight again, and then we go up. Here is a place where there's no moon again, and then the moon rises and we have that again, right? So we also see that there's a forecast for wind. And let's see, right now it says that my wind is supposed to be 12 to 16 miles an hour. That's pretty gusty. So that's not too good for a telescope, because especially if you want to be taking long exposures, because the wind likes to jostle the telescope around, and so your tracking it uh, isn't going to be all that great. So yeah, that's something to worry about. It looks like it's going to calm down uh, later in the evening, and that's sort of a typical thing. As you can see, it sort of gets windy in the afternoon and then calms down in the morning, and then gets windy in the afternoon again and calms down again and again in the morning. That's sort of a typical flow here. Um, Humidity. So you can see that at least right now, it's looking like it's pretty dry. This is the desert. So, by definition, deserts are dry. By definition, deserts are not necessarily hot, right? Antarctica is characterized as a desert, not because I mean, obviously it's not hot, but because it's dry. So the characteristic of a desert is that it's dry, and for sure, where I'm located, it's dry. And the last row is just showing you the forecasted temperature. And as you can see, we're starting to get nice and warm during the day, which is nice. Feels awesome. Feels awesome. So that's how to read those things. Pretty simple. Just time across here and sort of, your atmospheric um, conditions along here. And so you can sort of see, when is it going to be clear? When is it going to be cloudy? How's the seeing going to be? Um, how much darkness are we going to get? How's the wind going to blow? Is it going to mess up things? Um, yeah. So very, very awesome. And of course, this whole thing moves over time. So, we come back tomorrow, and of course, this section will be gone, and Sunday will be more filled in. In fact, I don't know if I can do it now. Let's see, we're going from 8 to 8 a.m. on Friday to 5 a.m. on Sunday. Let's see if I refresh it. If there was enough time yet to make a change. No, it doesn't look like it yet. I don't know when these are updated. I don't know if they're updated every day, every hour. I'm not exactly sure. I've never paid attention, mainly because I'm just interested in looking at the forecast, right? So as long as the next 48 hours, which is more or less what this is showing, uh, as long as that's there, I don't really care when it stops and starts. Cheers. Hey there, Warnock 69 Triple X. Hope everything's well. Heard you went to some kind of a car event of some sort. I've been paying a little bit of attention, not enough, but in any case, hope you're having a good time up there. I know that you're near P Town, so hope everything is going well for you there. Glad you could stop in. You can stop in anytime, brother, anytime you want. Very cool. We're just looking at the forecast here. Old school cars. Cool, cool. I'm not much into cars, but I I certainly uh, enjoy people who like them. So yeah, hope you're having a good time there. We're just looking at the weather. We're looking at the forecast. Um, the astronomers are sort of most concerned about the weather. That's our largest concern. Is it going to be clear? How clear is it going to be? How long is it going to be clear? Is it going to be clear enough? All these things go through my mind uh, uh, often, often. So this is just a tool. It's an online tool to sort of allow us to see what the forecast is, at least for the next day or two or so. So we can sort of plan our observations and get all excited about about that. So that's one of the tools that I use. Um, so the other site that I haven't showed much of lately, but definitely will and can, is the site called Heavens Above, which which allows you to sort of know when a satellite is going to be going over your location. And there are dozens and dozens and dozens of satellites every single day, that you can see, going from very, very faint to very, very bright. And so this is just a tool. It's an online tool, of course, that makes predictions based on where you are on the planet, um, to tell you which satellites are going to be going overhead and when. So this is one of those really, really cool um, um, things in astronomy where you really, I mean, don't use a telescope, don't use binoculars. It's all you have to do is walk outside and make sure that it's clear. That's it. And of course, you have to know when uh, these guys are happening. So um, you can um, set your location here. you can create an account as well, and then you can sort of have a permanent thing, or um, you can log in um, um, anonymously and enter your latitude and longitude. And if you want any help with that, I think they let's see, do they uh, somehow? Oh yeah, change your observing location, right? So they they even provide you with a Google map that allows you to to know exactly where you are. So that's very very cool. And yeah, that's close to my location, but that's not exactly it either. The this site, the CAC, um, is located right about here or so. So yeah, this marker is relatively close to me, but it's not exactly either. So no worries there. But you can type in latitude, longitude, and elevation, or you can click on the map and it'll fill in all this information for you. And then you can hit update, and you'll see up here that it gives you your latitude and longitude and your local time. See, so it says it's 1940:52 right now, which is correct. So once your location is known, then it knows, you know, it knows where all the satellites are, and so it can tell you when satellites are going to be going overhead. And you don't need a telescope, you don't need binoculars, you just need your eyeballs and a clear sky. Now, most satellites that you can see are going to be visible 1 or 2 hours after sunset and 1 or 2 hours before sunrise. And that's just because they have to be lit up by the sun in order for us to see them. So it's just like how the tops of mountains get lit up first at sunrise, and then you know, and then it goes a little lower, a little lower, a little lower until it hits the ground, and then you see a sunrise, right? So the same kind of thing. These satellites are several hundred miles up, and so they just see the sun first, and that reflected sunlight we can see down here, even though it's still dark here. So they do predictions for a few of the, you know, more notable satellites like the International Space Station. So let's take a look at that. Let's see when the International Space Station is going over my head. It looks like we're going to be having some low passes uh, today and um, tomorrow. So this is how bright the satellite is going to be. And yeah, as you can see, the altitude here doesn't get much above 11 degrees, so it's very very low. So it starts in the northwest sky and it peaks in the northwest sky and it ends in the northwest sky. So that's a very very poor pass. So is this one. So let's go ahead 10 days. You see, this is for the next 10 days. Okay, so let's go to the next 10 days and see if there are some better passes. Yes, there definitely are. You see how I think these are set up as a default. Uh, so, the pass basically starts when the satellite is 10 degrees up or higher, and it ends when it's um, 10 degrees above the horizon as well. You can see that this is using altitude and azimuth. That's one of the four coordinates systems that astronomers use to measure positions in the sky. And Alt-Az is used here because it's sort of a local coordinate system. It's for you. It's not sort of a universal one instead. So it just makes it easier because you know, and let's look at this bright one here on the 19th of March. You see, it's going to get really, really bright. It's going to get about as bright as Venus gets. So that's pretty bright, pretty bright. So it's at an altitude above the horizon of 10 degrees at 5:30 a.m. and it's going to be up in the northwest. So then, about 3 minutes later, it's going to be at an altitude of 82 degrees. So that's almost straight up, right? Straight up is what's called the zenith, Zenith, and that, of course, is at 90 degrees altitude. And the azimuth there is northeast. And then it's going to, 3 minutes later, it's going to move down to 10 degrees above the horizon in my southeast. So this whole pass only takes about 6 minutes, 6.5 minutes or so. So, it's moving pretty fast. I mean, it's got to move, 160 degrees in 6 minutes. Let's see. Now, the apparent motion isn't constant, but let's just assume that it is. Let's assume that it is. So let's say that it's 6.5 minutes and we're moving 160 degrees, right? Because 180 degrees would be from one horizon to another. And yeah, that's not exact either. But since it starts at 10 degrees above and goes over to 10 degrees above, you have to subtract 20 degrees from 180. I hope you follow that. So 160 degrees over about 6.5 minutes. So it's moving about 24.6 degrees per minute. So that's pretty fast. Let's go per second here. So that's about the distance of the full moon, the width of the full moon every second or so. There's another cool site. Maybe I'll talk about that maybe next time. It predicts when satellites like the International Space Station are actually passing in front of the sun or the moon. And so those are very, very exciting because then you can use a telescope, to magnify it a little bit. And when the event happens, it of course lasts about a second, like that, but it's very, very exciting. People like to photograph those or video them, and then watch it back and capture each frame, to see if they can see, the shape of the ISS and all of that. It's very, very cool. I'll try to bring that up at some point. If you click on the date here, that will show you the path of this satellite in the sky. So as you can see, it's a little hard to see here because we can't see the whole thing, but this way is north, this way is northeast, here's east, here's northwest, west, and of course south. South is down here. So you can see this is happening in the morning, right? So here's Scorpius, here's Sagittarius, here's Hercules, here's Boides, Ursa Major is over here, the Big Dipper is over here. We got Jupiter up, we got Mars up, we got Saturn up. Great, great stuff in the morning, of course. But here's the path that the ISS will take through the sky on the morning of the 19th of March, 2018, at my location, starting at about 5:30 a.m. And you can see the arrow here, right? So that is the direction of motion. And you can tell that anyway because you can see the times here. It says 5:31, 5:32, 5:33, 5:34. See, so now you can sort of see that it isn't constant motion, right? Uh, the apparent motion seems to be slower here than speeding up, speeding up, speeding up. Fastest right overhead. And that's just because it's closest to us, right? And now it's starting to move away. And so the apparent speed slows down until it sets in the southeast. So this is basically going what from northwest southeast. And so that is the path that it will take going through the sky. And I think, is there one more? There's also a ground track. So you can actually see from the ISS's point of view. So here's the path of the ISS in orbit, right? In orbit. And here is at least the location that this black dot here. It's not exactly my location, but it's pretty close. So you can see that it's almost going overhead, right? Really, really close. But here you can see that it is constant motion because this is the motion from orbit. Now this circle here, this is the horizon that the ISS sees. So since it's up, what, 300 miles or so up, it can see a lot further out. It can see way over into the Pacific here, way down past Baja, up into Utah and Colorado, over into Texas, right? It can see all of this. So what that also means is that in this circle, anybody in this circle can see on the ISS. And of course, since I'm right here, I can definitely see it. So yeah, that's just an interesting way of presenting sort of the same info. Yeah. So the other thing that you can do, let's go all the way back to the main page here, is we can look at the predictions for some brighter satellites. So these will be all the satellites that are visible to the naked eye for a particular site on a particular day. So it starts with the current day, and you can see March 2018, day number 2. So that's March 2nd, 2018, evening, right? And I can set the brightness. Let's set it to magnitude 5 because I can see all the way down to magnitude 5. And check out how many satellites I can see just tonight. Look at them all. How many are there? I don't know. There's a lot. Okay, so right now it is 7:52 local time. So I can go over here and I can look and see what satellites are up right now. Okay, this rocket body is going overhead right now. This one's about to. This one's about to. This one's about to. This one, another rocket body. There's a lot of rocket bodies. Those are usually like second stages or third stages that just haven't come down yet. So they rocket bodies tend to stay up for days or weeks or months. Um, Eventually, they do crash into the Earth again, but for a while they're up there orbiting, and we can see them. So let's see, this guy, 7:53. So this guy is up at the moment. So let's click on this time, and it'll give us the path, right? So we can actually see exactly where it is. Here's 7:52. Here's 7:54. So, okay, so it's 7:54 right now. So it's right there. So if I were to go out right now and look right there, I would see a little faint little dude moving along this way. You can see the arrow is which way it's going. Now, you may be wondering why this line just stops, right? Why doesn't it keep going? Well, this is the path of visibility. So this is when this satellite is visible. At this point right here, that satellite dips into the shadow of the Earth, and it becomes extremely dark. Extremely dark. I'm not going to be able to see it after that. So if I were to watch this, it'd be going along, going along, going along, going along, and at that point, it would just vanish, blink, like that. It would just be gone. And a lot of satellites do that. Uh, Most satellites do that. So yeah, there's a lot of satellites to observe. There's a network of people all over the planet uh, that just observe satellites because what they're interested in a couple of things. The first thing that they're interested in is observing them in order to improve the um, orbital parameters of of the satellites. Uh, if if you make an observation and uh, you can know where it is at a particular time, then you can sort of check that with the predicted orbit and see if it's right or not. And if it's you know to the extent that it isn't right, uh, that either means that the orbit parameters need to be tweaked a little bit, or, and this is the other thing that this um, network is I'm really interested in is if the satellites have moved, you know, like spy satellites, uh, they can move all over the place, and so these folks are um, really interested in those kinds of motions, and because they like to keep track of those kinds of things. Uh, and so, yeah, this is awesome stuff that you don't need a telescope for. You just need a dark sky, and um, you know, you yeah, if you want to observe all of these, you're going to be busy every single day. So this is just tonight, right? This is just tonight. I can look tomorrow morning, which would be March 3rd in the morning, and I can hit update, and I get a brand new list, and here they all are tomorrow morning. It's crazy. Look at all that stuff up there. Lots of rocket bodies. Lots of rocket bodies. Very cool. All right. I'm wondering if there's anything else on anybody's mind. Anything else at all? Cheers. All right. Well, I think we're coming up to the hour here, and I definitely, as I like to say almost every single time, I definitely respect your time. I appreciate you coming in, sharing some time in the circle, and yeah, having a great old time. I hope those of you who are watching this in the future maybe have just stumbled upon um, this show. Make sure to subscribe. You can hit the notifications to be told when I go live. But I do go live every single day at 2 hours UTC. I don't see that changing anytime soon. This is fun. This is fun. Uh, you know, uh, some people said, well, you're going to burn out and all that. But the fact of the matter is that uh, I I I've been uh, doing this for so long. You know, every single evening I'm here anyway, and I'm thinking about astronomy almost all the time anyway. So it's like, why not open it up to a circle of friends and you know, do that. So yeah, if you're new to the channel, make sure to subscribe, hit the thumbs up, hit the thumbs down, whichever you prefer. I'm mostly interested in the absolute value of your reaction, as opposed to, you know, whether it's a positive one or a negative one. Don't care about that. And please, please, please share this around. I want to grow this channel. I want to have a big circle of friends in here having a conversation um, about this thing that we are just incredibly passionate. Uh, um, yeah, I'm passionate about. And so with that, I think I'm going to get out of here for today. Yes, it is 3 hours UTC now. So I've taken up a good hour of your time. Greatly appreciate you coming in. And yeah, I think I will definitely, I don't even have to think about it, for sure. So far, tomorrow has always come. So I can be pretty sure that tomorrow I will be here again uh, doing some astronomy. We didn't do um, um, object of the day today. Probably tomorrow we will. Those are a lot of fun. I'm trying to think of other things too. Astronomy is really awesome because it's the study of everything, right? From the subatomic in size to the very short time spans up to, you know, the cosmological and very long time spans, billions of years. So you know, the science of astronomy covers everything, and so there's always something to talk about, whether it be new stuff, old stuff. The great thing about a live stream, a daily live stream, is that I don't feel any kind of pressure to try to pack in a lot of information because I'm only doing this every week, anything like that. I'm doing this every single day, so I can be relaxed, I can be casual, I can have a lot of fun, and just talk astronomy with a bunch of friends for an hour or so every single day. But for now, I'm going to get out of here. I will see you in a little less than 23 hours. And all right, take care and have a great day, great night. And yep, see you tomorrow. Bye.